Now that we can define sine and cosine, we will learn how they relate to each other and how they relate to the unit circle. Recall that the equation for the unit circle is x squared plus y squared is equal to 1. Now that we know that our x coordinate on the unit circle is equivalent to cosine of that angle that sweeps out to that point on the circle, and y is equivalent to sine of the angle that sweeps out and ends up at that point on the circle, I'm going to replace x with cosine of the angle, cosine of t, and I'm going to replace y with sine t. So if I look back up here at the equation of my unit circle, I'm going to plug in cosine t where I see x, so I have cosine of t squared plus, now I'm going to plug in y here, so I have sine t squared is equal to 1. And another way to write that is cosine with the little 2 up here for the exponent of 2, t, plus sine squared t is equal to 1. This is called the Pythagorean identity. In this example, I'm going to show you how you can use the Pythagorean identity to find the value of x if you know the value of y on the unit circle. Or in other words, if you're looking for the cosine and you know what the value of sine is. And you can do this in reverse too. You can use the Pythagorean identity to find the value of sine if you know the value of cosine. So starting with your Pythagorean identity, I have cosine of the angle squared plus sine squared t is equal to 1. Since I know that x is equivalent to cosine of the angle, and I know that y is equivalent to the sine of the angle, here is my y, which is my sine. So I know sine of the angle is 3/7. So what I'm going to do is I'm going to plug in 3/7 into my Pythagorean identity and try to solve for cosine, knowing that cosine represents the x-coordinate on the circle where that angle sweeps out. So here's my angle t where it sweeps out, and this would be the point that it lands on the circle. Okay, so I have cosine squared t plus, and since sine is 3/7, I'm going to have 3/7 squared is equal to 1. So I have cosine squared t. Now when I square 3/7, I get plus 9/49 is equal to 1. So now what I have to do is I have to subtract 9/49 from both sides. So I have cosine squared t is equal to 1 minus 9/49. And when I subtract that, I can take that 1 and change it into a 49/49. So when I subtract 49/49 minus 9/49, I get 40/49. So I have the cosine squared of t is equal to 40/49. Now, in order to solve for cosine t, I have to square root both sides. When I do that, I get plus or minus, don't forget your plus or minus, 40/49, which is equal to plus or minus the square root of 40/7, because I can take the square root of 49. So we have two possibilities here, and this is where we narrow it down to whether it's plus the square root of 40/7 or whether it's minus the square root of 40/7. If you notice, the point that we're looking at is in the second quadrant. Here's quadrant 1, here's quadrant 2, here's quadrant 3, here's quadrant 4. This angle sweeps open to quadrant 2. In quadrant 2, our value of x, or our value of cosine, is negative in quadrant 2. So my final answer is going to be negative square root of 40 over 7. That's going to be my final answer. So if I was in a quadrant in which cosine was positive or x was positive, I would be sure to pick positive square root of 40 over 7 as my answer if that was the case. But this is the case where we're looking at quadrant 2, so I have to make sure I pick the corresponding sign that goes with that quadrant.